Guys, so today we are reviewing for your test over sections 4.1 through 4.4. All right, so the first question that you're going to see is from section 4.1, where we are graphing linear equations with a table. And remember, when we're using tables, we really could use any x values we want. But there's a reason we choose very specific x values in order to keep our graphs reasonable. We don't want like really huge numbers that we're having to graph. All right, and we're to the point now where the substitution section, that really large middle section in our table, we can start doing that using mental math. That's okay. Now, if you want to continue showing how you're plugging in the value into the equation, you absolutely can do that. But I think for the most part, we probably could start doing that mental math. Would you agree? All right. So what am I doing with these x values? What am I doing with these x values?
Miss Kendra.
Okay, so what's negative 2 times negative 2 plus 1?
Negative.
5. Because negative 2 times negative 2 is positive 4. 4 plus 1 is 5. 0 plus 1 is 0. And negative 4 plus 1 is negative 3. All right, who got that table correct? Odds are if you missed one, it might have been a sign. Okay, so now let's visualize. All right, because we have so many graphs today, we're not going to spend a ton of time actually graphing them. But let's visualize where these points would go. So negative 2, 5. Go ahead and kind of pinpoint that on the screen. Negative 2, 5. All right, are you picturing it right about here? All right, now what about 0, 1? Right here? Okay, and then 2, negative 3, right about there? Okay, and arrow going through it. And just based on the way my graph looks, how can I know that I'm probably correct? It's not zigzag or curved. It's a straight line, all right? And it's supposed to be a linear equation. All right, so graphing linear equations with a table. That's your first question. Now we're going to find slope. And there's two methods to find slope. I think there's still a little bit of confusion as to which method I use when. So hopefully we can clear that up now. We use rise over run when we have a graph to read the slope, okay? So because there's a graph right here on the screen, where I can count rise over run, I'm going to use that method. There's no point in pulling out the ordered pairs and plugging them into the formula when I can simply count the units. All right, could I? Absolutely use the formula, but that's not the most practical method. All right, so between the 2 points, I want you to count the rise over the run and make sure you simplify that fraction. And then just tell me, which way do we read a graph, guys?
Left to right.
Left to right. So if you read it in the correct direction, the positive and negative part of it should pretty much be a give me, okay? So if it's sloping down, it's negative. If it's sloping up, it's positive. All right, go ahead and answer this one. Sarah, what did you put for your slope?
I put negative 4, 4.
Okay, so she put negative 4 over 4, which is correct because, guys, remember, your run is never going to be negative. From left to right, you start at this point. You don't go backwards, ever, okay? You're always going forward, so the run is always positive. What is negative is that from the first point to the second point, the points are going down in value. So that means your rise is negative, and that would simplify to negative 1 over 1, or just negative 1. All right, but we talked yesterday, not necessarily for this problem, but we talked yesterday about why it would be beneficial to leave the slope as a fraction. Does anybody remember why is it helpful to me to leave slope as a fraction? Sarah?
Because if you wanted to graph like the slope, you would have to use negative 4, graph it, and then 4.
Yeah, very good. Okay, so if I were actually graphing this slope, I need to know that there is a value for the run, right? That it's not nothing, that it actually is over 1. All right, so is my slope positive or negative?
Negative.
It's negative. It's clearly from left to right going down. All right, so it's negative. So don't overthink that, guys. All right, now I need to find slope on the next problem. Well, what don't you see on this screen versus the last screen? What's gone? The graph is gone. So now I'm not going to use rise over run, because by the time you graph these ordered pairs and count the rise over the run, you probably could have solved 3 of these using your slope formula. So again, we're looking for the fastest, the most efficient, right? We don't like creating more work for ourselves. So now the fastest way to find slope is using our formula. All right, so here's the part I can't help you with. If you don't have the formula memorized, all right, I'm telling you, you do have to have it memorized, but if you don't have it memorized, you really have no chance at getting this question correct. All right, so first of all, we need to write the formula. Okay, what is the formula, Ethan? Okay, he's exactly correct. All right, so it is y2 minus y1 over x2 minus x1. But this still makes absolutely no sense to me if I don't understand which values in the ordered pairs stand for which label in the formula. So how do I know which number is my y2 and which number is my x1, my x2, all of the values, Joshua? The order of it. So let's go ahead and label the ordered pairs. Can we say it together? x1, y1, x2, y2. And this is the same every single time. The sequence is always the same. I had a couple people ask me different questions earlier, like, well, what if I have 3 ordered pairs? Or what if, only 1 ordered pair? Well, in order to find slope, you can only have 2 ordered pairs. So if this sequence is true every single time, now we can plug the values into the formula and solve. Okay, go ahead and do that. I'm going to come around and check your work. Okay, so y2 is 4 minus y1, and y1 is already a -2, so the subtraction sign is in my formula, and what happens when I plug in a -2? It becomes a positive over -3 minus 3, okay? Now something interesting happens here, okay? Now my double negative changes to a positive, but my negative is in my run. And all throughout this unit, what have I told you? Your run can never be negative. Okay, so what in the world do we do if the negative is in the denominator? We need to understand that this means it's a negative slope, okay? But because our run can never be negative, what will be negative? The rise. The rise will be negative. All right, now this doesn't happen often, but anytime we have a negative at all, we are going to write it in the numerator, and we can do that, all right, according to commutative property. Basically, if there's one negative in the fraction, we can attach it to either numerator or denominator. All right, so my slope is -1. All right, next one, proportional relationships. So now we're in section 4.3. Up until this point, this is everything that you were quizzed over on Wednesday. Right, a lot of you did very well in the quiz. But now we're getting into the second half of the unit. And this material you have not been quizzed over, but you will be on Monday. So in order to determine if a set of values is proportional, I need to compare each XY pair. Okay? And here's what I'm looking for. A pattern of multiplication or division from X to Y. It's never going the other way. From X to Y, is there a pattern, meaning I'm multiplying or dividing by the same number to get to my Y value? If there is, it means that these ordered pairs are proportional. If there's not, then it means no, okay? So go ahead and try to find, if there is a pattern, you're going to write it as an equation. If there is not a pattern, you're going to tell me which ordered pair breaks that sequence. Usually it's only going to be 1, maybe 2 ordered pairs. Okay, probably only 1. All right, we'll just stick with that. Okay, so what operation gets me from 3 to 9? To times it by 3. So now all the other sets have to be the same operation for it to be proportional. 5 times what is 15? 3. 7 times 3 is 21. And 9 times 3 is 27. So this pattern of multiplying by 3 is consistent across all of the ordered pairs. They are all the same, which means I do have a proportional relationship. I can write this in an equation by saying y equals, what did we say that we're doing to x for all of them? Multiplying by 3. So that's the operation that connects to x. If you had said divide by 3, it would have been 1/3 x. If you had said multiply by 5, it would have been 5x. Okay? So whatever you're doing to x to get to y, that's what you write in the equation. Okay, so that's proportional relationships when we're looking at tables. Now let's look at them on a graph. There's one determining factor to determine whether or not a graph forms a proportional relationship. All right, we did learn this the other day. I just want to give you a minute to see if you remember, and then we'll talk about it. All right, yes or no, and then tell me why. Okay, and my answer is yes or no, guys? No. It is no. Why? It does not pass through the origin, okay? So if the answer is yes, it's because it does pass through the origin. And just as a review, what is the origin? 0, 0, right here in the middle, okay? And the line clearly does not pass through that point. All right, so proportional relationships. Now we're in section 4.4. This is a pretty large part of your test. Okay, to identify slope and y-intercept. This is on your quiz, your review sheet, and your test. All right, now there's one thing that I have to do before I can say m equals this and b equals this. What do I have to check for before I can say m equals and b equals? Trey? Y is by itself. And what does he mean by that? He means, is it in slope-intercept form? Is it y equals, and then the x value, and then the b value? All right, now on the first one, is it in slope-intercept? Yes. Yes, because y is by itself. So now I can go ahead and pull out my m and my b. All right, go ahead and do that. Caitlin, what is my m value? What is my m value? 7. Okay, my m value is not 7, but what is it, guys? -7. Okay, you've got to recognize that negative in front of the number. All right, and what is my b value? 12. All right, so let's visualize the graph here for a minute, because when I'm graphing using slope and y-intercept, this is actually all the information I need to know. All right, where would my first point go on this graph if I were to graph it?
12 on the y.
Very good. My b value tells me where the first point goes, on the 12. And where would I go from that point? Where would I go? Just tell me.
7 down.
Very good. I would go 7 down and 1 across. Okay, so -7 over 1. I would go from the 12, I would go down 7 and to the right 1 unit. All right, we'll show that in a graph in just a minute. Okay, let's look at the second equation. Go ahead and write that down. Y minus 6 equals 3 over 8x. Okay, very good. Very good. Now, is this in slope-intercept form? Again, that's the first thing I need to check for. No, why?
Because the y is not by
Y is not by itself. So the first thing I need to do before I pull out my m and b is get it in slope-intercept form. All right, go ahead and do that, and then pick out m equals and b equals. What do I do to both sides? Add 6 to both sides, and now I can clearly see what is my m value.
3 over 8.
3 over 8, whatever number is connected to x, and what is my b value? 6. So let's visualize the graph again. Everyone, where would my first point go?
6 on the y.
On a y value of positive 6. My b tells me that. Now my slope tells me where I go from there. So from the 6, where do I go?
3 up and 8.
3 up and 8 over. And remember, my run is never negative, so I'm going 8 to the right. Okay, and of course my slope is positive anyway. All right, so now let's look at a graph. Again, this is not something you need to do on your paper or on your whiteboard. You can just simply look at the equation with me, all right, just due to the fact that it's a chapel day and it's a short class. We're just going to look at it and kind of visualize where these points are going to go on the graph. All right, where would my first point go? Where would my first point go? on a y value of 4. Now, how do I know where to go from there? How do I know if I'm going up, down, left, or right? What tells me? Very good. I need to look at the slope. My m value is what? Negative 2 over 1. So now I go down 2 over 1, and I plot my point. Okay? And then I draw my line, and I'm done. All right, so just graphing using slope and y-intercept. I think you'll find the more we practice these methods, you'll probably prefer this method over using a table. However, the tables show us that we have a class of 20 students. You all could choose different values, and the y values matched together make solutions. So basically, there are infinite solutions to linear equations. All right, so parallel lines. This concept is important. You have, I think, 2 of these on your quiz and test. Are these lines parallel? Well, there's one rule that either makes lines parallel or makes them not parallel. But I'm not ready to compare them. Why am I not ready to compare them? Very good. The first one is fine. It's in slope-intercept, but the second one is not in slope-intercept by a long shot, okay? So go ahead now and write the second equation in slope-intercept form. Okay, so first thing I need to do to both sides, first thing I need to do, subtract 4x from both sides. Now, can I do 6 minus 4x and say 2x? No, they're not like terms. According to slope-intercept, which one of these terms do I write first? Which one do I write first? Negative 4x, because my x term needs to come first. Then plus 6. Now what do I have to do to all the terms? Divide everything by 2, again, because my goal is to get y by itself. So now that I have both equations in slope-intercept, are they parallel?
No.
Yes. Why?
Because the m is the same.
The m is the same slope. Okay? You've got to tell me same slope, because now on paper, in words, I can't talk to 55 of you and make sure you understood why. So the yes part of it, you just need to recognize, okay, same slope. Okay? Now, if it's no, it's because your slopes are different values. All right? Yes, and same slope. All right, you have a modeling real life. Okay, we always have these word problems on our quizzes. So let's read this scenario together. It is very similar to what you're going to see on your quiz and your test. The total amount, okay, so this is important. This is going to be my y value. The total amount in dollars in your savings account. So how much money you have in savings, that's your y value. After buying, don't know how many video games, so x stands for how many video games, is represented by y equals 80 minus 10x. You have $20 in your account after buying video games. How many video games did you buy? Okay, so this $20 value, I have to figure out, are they telling me that's how much in savings, meaning that's my y value, or are they telling me how many games I bought, which would be my x value? Which variable does 20 plug into? Yeah, 20, no, not x. Look, $20 is my y value. It clearly says this is how much I have in my savings account after I buy the video games, and then it asks me how many video games, so that's what I'm solving for is x. All right, so what I'm going to do is plug in 20 for y equals 80 minus 10x. Okay, so now I need to just solve the two-step equation. Subtract 80 from both sides. It's going to look a little questionable here at first. Negative 60 equals negative 10x. What do I divide both sides by? Negative 10. Okay, and a negative divided by negative is positive, so x equals positive 6 games. That's how many games I bought. Okay, and if I were to plug this back into the formula, 80 minus 10 times 6 would be 80 minus 60, which gives me $20 left over. All right, so your challenge on your quiz on Monday is going to be figuring out which value is being plugged in and which value you're solving for. So watch for those indicators on y stands for this and x stands for this, okay? If you understand that, that's everything you need to know for your upcoming test and quiz.